Welcome to our video on denormalization, a powerful technique for boosting reporting database performance. We'll start by looking at the ideal scenario for database design, normalization. The goal of normalization is data consistency, which is crucial for systems with frequent changes. Voice code normal form is ideal for databases with frequent inserts, updates, and deletes, ensuring efficiency and consistency. However, sometimes an ideal database design can be too slow when it comes to reading and analyzing large amounts of data. In databases used primarily for reporting, changes are infrequent, which changes the design priorities. Here, redundancy is acceptable, and sometimes even desirable. Redundancy can make queries faster and simpler by avoiding complex joins. This brings us to the concept of denormalization, a deliberate strategy to improve query performance. Denormalization means intentionally introducing redundancy by merging tables to streamline data access. The main benefit is eliminating resource-intensive join queries, which dramatically improves query performance, especially in reporting. However, denormalization is not without its trade-offs, and it must be applied with care. When denormalizing, you intentionally fall back to first and second normal form tables, which means accepting more redundancy. It requires balancing performance gains against the increased data redundancy and potential for data inconsistency. Let's consider a practical example using a booking system. In a normalized booking system, you would have separate tables for booking, passenger details, and fare information. To denormalize this, we merge the booking, passenger, and fare tables into one larger booking table, incorporating all necessary details. The result is a table with intentional redundancy, which is a key characteristic of denormalization. This single table now contains repeated passenger and fare details from multiple booking records, which is the redundancy we introduced. Crucially, this redundancy speeds up reporting queries by completely removing the need for time-consuming joins across multiple tables. To summarize our findings on denormalization. Denormalization is a deliberate design choice, not an accidental one, made to optimize for read performance. In reporting databases, it simplifies queries and dramatically improves performance, accepting redundancy as a necessary trade-off.
Let's look into our denormalization example. So we have a figure that has the booking table, we have the passenger table, we have the fare table. So when we bring these tables into a single booking table, here we have the passenger number, the passenger name, the flight code, the fare class, and the boarding zone. So when you bring them together, we identify that a variant was appear multiple times and is booking actually the same fare class, and the boarding zone number is the same. So this highlights specific. The red highlights areas that have the denormalized zones in the denormalized table. So let's do the questions to help us understand further. So denormalization, question 1, this is a participation activity. You can work on it as we go on and give the answer as we read through. Denormalization never results in a second normal form table. Is it true? Okay. Denormalization improves performance of call select queries. Okay, then occasional tables are denormalized in a frequently updated database. Okay, let's see. Denormalization never results in a second form of table. Let's see if it's true or false. It true says it's correct because denormalization can introduce a dependency of a column on another non-key column, resulting in a second normal form column that is no longer in that normal form. So it never results in a second normal form table. So that is not true because it results to a second normal form table that is no longer in the third normal form. So denormalization can introduce a dependency of a column on another non-key column, resulting in a second normal form table that is no longer in the third normal form. Alright? Then let's go to the second question. Denormalization improves performance of all select queries. Let's look at multiple choice 1, 2. Okay, denormalization typically improves performance of joint queries. The performance of a query that can access a single table is not usually affected significantly. So denormalization does not improve performance. Denormalization typically improves performance of joint queries, but not all select queries. The keyword here is all select. So performance of queries that access a single table is not usually affected significantly. Okay, go back to my video so that we understand the term select queries. Get deep into it so that when we read about a select query, you know exactly what is a select query and you know exactly what is another forms of queries, of course. So occasional tables are denormalized in a frequently updated database. Okay, let's see the truth part of it. So database that experience updates may have some static table containing and changing reference information. So although tables that experience updates are usually in third normal form, static tables are occasionally denormalized to improve performance. So the other side is the false part does not work because databases that experience updates may have some static tables containing and changing reference information, although tables that experience updates are usually in third normal form. Static tables are occasionally denormalized to improve performance. So correct answer here